It's also interesting to see how many new people are here who haven't seen this before. So maybe your first hint was that about the slide up here, nothing you're about to see has passed anywhere remotely close through marketing or any sort of corporate communications officer whatsoever. So fair warning. The other thing I should mention is we do have around 140 or so people on the remote side. So for interactive folks, for people who are watching remotely, please feel free to use the Pathable platform, send in your comments, send in your chats, and we'll try to be monitoring that, and we'll try to take some questions from the virtual crowd as well as the people who are here in person. So with that said, I've got my timer going so I keep myself on track. There's a very particular reason why this slide is up here. I'm not up here because I'm particularly good at my job. I'm not up here because I'm a thought leader, a pundit, an industry, an influencer. The reason why I'm here really has to do with the facts of my job. I work in the consulting space, which means I get to see how 15 or 16 different groups of smart people tackle similar problems year over year. But also, I generally tend to work in areas where I have relative freedom to talk about what I see, including when I see things happening over and over again. So I'm not here because I'm an expert. I'm not here because BioTeam. I'm here because the number of practitioners doing work down in the trenches who are in a position to do public speaking and speak candidly is relatively small. So I'm what you got. There's a lot of people who are better, smarter, faster, and have more interesting things to say. And part of the sort of rework of trends is to try to start to bring other voices into the fold. So I'm here because I'm able to speak candidly, not because there's anything special about what I'm going to be telling you. So a little bit about, I think Kevin did most of the introduction here, but yeah, this has been going on for a long time. And I think really what happened is we started coming to events like this, pausing. All right, technical issues.
Only half of us are here. The people virtually, you should see the chat. They're chanting for you.
All right.
They're just not seeing and hearing.
All right. So does that mean you want me to back up to slide?
Ideal.
All right, so we're back to friends from the trenches. Sorry about that. So I guess, while we fix those issues, the other thing I'm notorious for is having a huge number of slides and speaking really quickly. Back when this was a 90-minute session on my own, I did 160 slides in 90 minutes. But I am probably going to have to speed up what I'm saying if I'm going to keep us on track, although I think we do have a soft ending because we go into a break after this. So, all right.
So we have extra 15 minutes.
All right. Okay, all right, so engineers. All right.
Does anybody know any fun trivia?
Yeah, I'm not Kevin. I'm a technical guy. I can't do small talk.
Well, I'm working at it.
All right. All right, I am going to reset my timer a little bit.
The treat in the hall is brownies. Oh no, you're going away. The treat in the hall is brownies. Yeah, I don't think my microphone's on. That's probably for the best as well. Sit down now. Trends is a little bit, there was the time that we unplugged the video in the middle of the trends talk.
Yep.
I feel like there might be somebody that Dax doesn't like comes behind him and puts some little gremlins in the process.
Yep. I could talk about that title picture, which really is a hole in the ground. So I'm also semi-notorious for building a yurt in the woods of western Maine and running a 10 gig fiber out to it. So I have a 10 gig equipped fiber yurt on the Androscoggin River in Maine, and that's actually the trench we dug to run the fiber out to the yurt. So when I was doing pictures for the slides, it was the only trench-oriented picture I could really find, so that's what you get.
There's a lot of roots in there.
Yes.
You just need to go under that with the cable.
Yeah, well, all right, so you have to run it, basically we had to go down a certain depth to one of the things, so Maine is kind of weird. Some towns are Wild West from a zoning perspective. You could do whatever the heck you want. And in the town I'm particularly in, they actually have code enforcement and rules. So we want to be good neighbors. We don't want to be massholes is the term. So we follow the rules when we're in Maine.
So what do you do in your yurt there?
Actually, that's been my COVID remote office. Working from home has been easy for me because I've been doing it for 20 years. My wife, who is smarter, better, and more strategic thinking than me, is a VP. She's C-level leadership at a gene editing startup, and she always thought her career was going to be going to the office every day and having a highway commute every day. COVID sort of changed that, and now we worked at home. But the problem is My wife deals with FDA information and stuff that could materially affect the stock market, so she talks about things that I'm really not allowed to hear. So our big COVID issue was not home office, it was setting up home offices that were not in audible earshot of each other, so I can't hear the confidential stuff she's talking about. And so when we're in Maine, she's in the log cabin and I'm in the yurt. That's the, because I am not allowed to hear what she talks about at work.
Who has the bathroom?
Oh, that's a good question. All right, so yeah, I've run back to the yurt, or sorry, run back to the cabin for that. Yeah. The one rule about the yurt is I was not allowed to put running water in it. It's too close to a river line. So there's no facilities in the 10 gig yurt. Oh, and for those of you who are technical, if you think having a 10 gig connected yurt is a big deal, the embarrassing thing is it goes back to the cabin, which terminates in a really crappy business DSL connection. So it's 10 gig local. It's crap to the outside world. Yeah. One of my neighbors made an aesthetic decision to not allow telephone poles, so all of our utilities were underground, which means we are being skipped in the fiber broadband rollout in Maine. So hence the crappy DSL connection. Yeah, I'm on the wait list for Starlink, but you know, Elon hasn't gotten back to me. No.
You may have a better COVID work story, because that one's pretty good.
Yeah. Yeah, I mean, you know, it's funny, the COVID stories, everybody, you know, all of my friends and colleagues, you know, they have homeschooling and kids and pets and everything else. My only issue is, yeah, my wife deals with stuff I'm not allowed to hear, you know. All right. All right, folks, thank you for your patience. We're back. I'm going to reset my timer and get going again. And I will quickly just explain that just really the point of this slide. Sorry for those of you who've heard it before, but basically I'm not here because I'm particularly awesome or particularly skilled. The reason why I started doing talks like this is that I have an enviable position of working as a consultant, which means I get to see lots of different stuff over the course of a year, but also I'm in a position where I'm allowed to talk relatively freely about what I do. So there's a lot of people out there who are better, bigger, smarter, faster than me. Most of them are working for entities that put a relatively tight leash on them when it comes to public speaking or public disclosure. So, you know, Kevin did the backstory here, but in reality, the reason why I've been doing trends, the reason why I've been coming up here is basically an artifact of my job and not because of anything I'm particularly awesome at. So just to recap a little bit, you know, all of us have an idea of what a good meeting is or a good conference is. You know, my idea of a good meeting was supercomputing. And then we all have ideas of like sort of the bad sort of junket-infused meetings that happen to be held wherever there's a nice golf resort or something else. And, you know, the talks are thinly disguised sales pitches by people who've paid to be at the podium. And, you know, that was kind of my early career influence with coming to BioIT World. I said, hey, I'm doing this stuff. I'm doing it in the trenches. I want to be, you know, I want to tell you my mistakes. I want to tell you what's worked for me. I want to tell you what hasn't worked. And I want to be honest about it. And so it turns out that, you know, showing up with a slide deck and speaking really quickly, but being kind of blunt and fairly honest, it was actually kind of cool. And it sort of kicked off, you know, BioTeam's relationship with BioIT and CHI in that we did a lot of the groundwork and we try to hustle and sort of keep the quality of the content. And we like to see practitioners behind the podium, and we like to see a little bit less of the sort of, you know, thinly disguised sales pitch. So the sort of genesis of Trends from the Trenches has been, hey, let's get practitioners up here, and we're just going to talk bluntly about the good, the bad, and the ugly. That went on for a very, very long time, 11 years. Like I said, you know, I'm notorious for doing a 90-minute session with 160 slides in the past, trying to transition away from that right now. So as part of that, I'm getting old. I'm running out of stories to tell. I've found my lane in my career. And like I said, there's better, younger, smarter, faster, more interesting people out there. And it's time to sort of revamp trends and start bringing in new voices, in particular because one of the things I like to disclose is, you know, I work in a very particular niche, and my words and my opinions are specific to that niche. I tend to do a lot of commercial and industrial work. I tend to work a lot with pharmaceutical and biotech. BioTeam as a whole works at a far broader scale than that. We work all over the government. We work all over nonprofit. We work all over higher ed and K-12. And so one of the other reasons for bringing other voices up here is a lot of the stuff that I'm telling you personally is filtered through a commercial biotech or pharmaceutical viewpoint, and there are other viewpoints and there are other sort of answers and experiences to share. So the transition from trends to friends is sort of bringing on other people and other voices. And we are working off of a common slide deck today. We tried to work off of common themes, so hopefully this will flow nicely. We've tried in other years to do panel discussions with split talks, but the flavor we're going with today is all of us speaking off the same deck, trying to tie our words together thematically, but allow me to stop speaking and allow other voices to get up to speed. So the other friend I need to mention is the OG friend Stan Gloss at BioTeam. One of the things that he's done, besides being my friend, my boss, and the co-founder of BioTeam, is he stepped aside from CEO position and kind of took on kind of a chief storyteller role for BioTeam. And he spent most of the last year and a half really traveling and interviewing people who truly are, influencers, industry leaders, visionaries, and getting their words there. And I've been reading some of the results of those interview recordings. I watched a couple of Zoom sessions, and if you really are interested in big industry-spanning trends and where visionaries think the future is going, the collected stories and interviews that Stan put together is going to be really, really interesting. The only thing I can say here is coming soon, because I don't think CHI has figured out how this is going to be distributed, but eventually I think there's going to be like an ebook or a publication of sort of Stan's collected stories, and I think that'll be a very, very interesting read. So just sort of keep your ear out or keep your eye out for something like that coming down. So, time to bounce into my particular stuff. I'm going to go a little bit longer and then hand it off to Adam. Adam will hand it off to Carl. Carl will hand it off to Fernanda. And then we'll have a nice Q&A session with Kevin Davies sort of wrangling us cats. So I want to try things together. I wanted to sort of tie things together in terms of persona, POSIX, policy, petabytes, and then try to break up a little bit of words about each rather than do a 90-minute session, just shotgunning information at you. So the first thing that's really sort of happened is, I didn't really want to talk about all of the sort of obvious stuff from work from home and remote work and what COVID's done, but in reality, that has had an effect on both research IT, enterprise IT, and the way we design and build and deliver scientific and sort of discovery solutions to people. In particular, it's not just that the size of the remote workforce has grown. It's that we now have startups selling remote API-driven laboratories as a service, so you don't have to go into a lab anymore if you're a wet lab biologist. The other thing that's really interesting is we've gone away from fixed offices. I used to be able to put my data science people in a particular part of the office floor, and I used to be able to run 10 gig data drops to them because I knew the data science people needed that. Now the issue is a little bit more interesting. We have people making reservations for their desks, and I might have the data scientist sitting next to someone from commercial ops, both of them who have very different risk models and both of whom have very different access to sensitive data sets. But now they're sitting in the same place, they're on the same VLAN, they're at the same top of rack switch, they're on the same Wi-Fi access point. And so what I'm starting to see is that it all boils down to our traditional approach to security and enclaves, this sort of hard shell approach with the firewall. And once you're inside the premise or once you're through the firewall with the VPN, you're kind of trusted and you're able to kind of move laterally through the organization. That era is kind of fading away. That hard shell methodology to information security is definitely obsolete in 2021, and you're starting to see the downstream effects of that, particularly even in the R&D and discovery space. The other thing that's happening is, edge computing is one of those buzzwordy things that's actually becoming real. We have to deliver more power, more services, and less latency to people who are increasingly diffused throughout our organization or possibly throughout the country or throughout the world. And then the other thing we're starting to deal with is smart devices, Internet of Things, sensors, particularly sensors that have dodgy life cycle, unpredictable hardware or hardware upgrade or patch them when something goes wrong, and having a nasty tendency to sort of chat promiscuously with unknown destinations on the internet. There's a real issue that we're starting to see now with all of these smart devices being peppered throughout our organization that we really don't have a lot of control or visibility into what they're doing. So what that's really boiled down to is, for me, what it's seen in the effect in my work, in our network design and our security work, is that the concept of identity, authorization, device profiling, device discovery, that no longer exists at the shell or at the perimeter. It's a capability that has sort of diffused throughout the entire organization, both labs, premise, manufacturing, but also our extended network of links to collaborators, externals, VPN working remotely. And that is bringing up a whole new set of buzzwords and capabilities that are starting to show up in the R&D space for me. Old network heads, this is old school stuff, port level network access control. But we're starting to really, when we were talking about device inventory and device discovery, we used to be talking about just laptops. Now it's, okay, what's that strange sensor that's attached to a refrigerator? Why is it talking to a weird destination in an unknown country? that sort of thing. We're really starting to have to up our game, not only with automatically identifying and discovering devices on our network, but applying automated rules about where and what they're allowed to talk to, because there's a lot of strange stuff popping up on the network. And then finally, all of that ultimately boils down to the buzzword of the day, which is now zero trust. And those of you who know me, I will call out the BS-lated marketing stuff. Zero trust is definitely in the realm of trust but verify. Your vendors are probably lying to you. The marketing people are probably running amok. The proof of concepts are probably sponsored or artificial. And so you really, this is one of those areas where you do have to sort of independently verify what the claims are, particularly if they're trying to sell you something. ML and AI used to be that way, and a couple of years ago. Capital G, big grid computing was that way years ago. ML and AI is clearly over the marketing hurdle. It's real. You could tell by the talks here. Zero trust and anything involving next-gen level security, whether it's endpoint EDR or whatever, definitely in the realm of be careful because the marketing people are in control, and they'll be in control for another couple of years before things start to settle down. So moving on from this concept of persona, really the takeaway there is like this concept of security has really had to diffuse through our entire organization, including our external web of contractors, collaborators, and externals. Transitioning now into POSIX, which is a fancy way of saying there's a lot of stuff I've been saying over and over and over again for many, many years. I'm definitely one of the believers that thinks the future of scientific data at rest belongs in an object storage system. I'm not a fan of files and folders. I'm not a fan of designing storage systems where the primary consumer design, the primary design is for a human being to click through files and folders. At petascale with trillions of files, we're clearly beyond that. We have storage systems and data that no human being will ever browse. It doesn't make sense to design storage architectures for human consumption, at least as the primary driver anymore. It's all about automation, analysis, and sort of automated discovery of your data. I've also talked a lot about the friction. The problem was is storage got cheap faster than the cost of managing storage got cheaper. So there's a huge imbalance in that it's really easy to tell your boss you want to go out and download a few petabytes of open access scientific data, but it's very expensive and operationally burdensome to keep that data available, make it fast, make it performant, make it protective. And so there's been this friction where it's easier to acquire data than it is to actually manage data. And one of the trends I'm starting to see this year is I think that we've hit the inflection point. A lot of my customers refuse to have the difficult I have a lot of IT leadership or organizations that refuse to have difficult conversations with their scientists. So rather than have the conversation about managing, curating, and moving data around, they would just endlessly shift money into their storage arrays, making them bigger and bigger and bigger and bigger, and sort of defer the management decision until down the road. There's signs that that's starting to change now as well. I will say that one of the biggest shifts in storage design and architecture is it's really freaking annoying the ML and AI people. What they've done is we used to be able to buy a storage design in life science to make it big because the existential dread is running out of space because the rate of data that we're acquiring or generating is massive. The design trade-off is I used to be able to give scientists big, massive storage systems that weren't particularly the fastest in the world, and they were willing to trade off a little bit on performance because we solved their capacity fears. The problem with ML and AI is that, and even cryo-EM, is that the equation has shifted. We actually need really fast storage now if you're going to make your cryo-EM people, your ML people, and your AI people happy. The other thing that this has done to storage design is I used to be big on tiering and namespaces. Tiering and namespaces in archive gets a lot harder when you're doing ML and AI because ML and AI always needs to go back to the old data to retrain or reclassify. So, some of the biggest sort of architectural changes have really been the rise of ML, AI, cryo-EM that have basically forced us to build very large single namespace, highly performant storage systems, and that's actually something that we were luckily and able to avoid for a fairly significant period of time. I'm going to skip my coddling down at the bottom, but I can say, I hit the wall and I was a little bit profane last year when talking about this. There are scientists who've built entire careers and long citation records on data-intensive science who actively refuse to, lift a finger to manage, curate, or organize their data. They just sniff in the air and tell me that that's an IT job. I'm done with that. If data-intensive science is your job, it's your freaking responsibility to take some ownership in your data. And if you're not willing to, have that conversation with me, you've lost your seat at the table. And I'm no longer friendly about that. It's been annoying enough that it's time that if data is your job, managing data is also your job. It's not the IT person's responsibility anymore. So the thing that, I was really racking my head and trying to figure out what's actually changed in 2021, and it's actually really weird. The most significant change in my consulting work in 21 has been the overwhelming percentage of my biotech and pharmaceutical customers that have bought all in on Ignite.com storage. I work a lot with early stage startups and pharmaceutical companies, and I think a significant majority of them are all in on Ignite. And it's not just for humans. They're sort of using that as the heart of their instrument data capture and data collection system. And I think a lot of my consulting work in 2021 and beyond, or 2022 and beyond, is going to be figuring out how to bring that type of stuff into the fold of sort of petascale, technical computing, Linux-heavy scientific computing, analytic environments that have petabytes of data, when I've got entire companies that are betting their storage architecture on kind of like a Dropbox-style distributed client that basically runs on laptops. And so I'm not going to read all the words about Ignite, except to say that, man, their marketing is great. They hit all the checkbox that a C-suite executive would want for buying something, and it's really nice. I have to say my clients are happy with it, but I start to dig in a little bit, and okay, the largest file I can stuff in a share is 100 gigs. That doesn't work for imaging. That doesn't work for some genomes. That doesn't work for live cell stuff. That doesn't work for a video coming from an animal facility. They're all Windows or Mac-based GUIs that assume the dominant consumer is a human being browsing files and folders, which you already know my thoughts on. We have trillions of stuff. I'm not really sure, in petabytes most of us have. I'm not really sure how we sort of integrate this into a petabyte-capable analytic environment. But in particular, these clients have a particular contempt, or they flat out ignore Linux, which is a kind of a big problem for us in the scientific computing space, where most of our analytical power is Linux-based. And then finally, anytime you have a Dropbox, Box, or Ignite-style replication agent, anybody who's done any significant cloud work knows the effect of egress fees and paying per gigabyte for data that leaves your traffic. So I'm also fairly concerned about replication traffic for stuff like that. So this is kind of the nutshell of my complaint here is their website proudly claims we solve 100% of enterprise file use cases. That's how you know the marketing department is unsupervised. The second thing is, I followed a link on the website that said file server replacement. I thought, oh, cool, they've got like an AWS storage gateway or something that can kind of replace. Nope, their solution is to delete all your file servers and put the Ignite client on all your laptops. Because to them, that's the only thing that matters. Human beings browsing files and folders. And then finally, I clicked on, oh, cool, let's see what they propose for AWS. Oh, it's putting the files and folders agent on a virtual desktop. They haven't really solved my auto-scaling HPC cluster or running compute out of an S3 bucket problem. So you can see this is a major trend for me. And ultimately, I really don't want to trash Ignite. And actually, I will candidly say my customers are actually very happy with them. I have no intention of fighting them, kicking them out, blocking them, or doing things. My job as a consultant is to figure out how to make it work in my world. And my world is petascale, highly performant, scientific computing, have to integrate object storage, petabytes, lots of readers and writers, and honestly, I'm a little bit worried. It's going to be an interesting paradigm. The best design pattern I can come up with right now for an Amazon environment is converting all of my scientific computing over to Windows file sharing protocols and selectively syncing stuff like this into the, the AWS equivalent of a managed Windows file share. So I'm a little bit nervous about that. So moving on, so that actually was an honest trend. If you want to take away from the POSIX stuff, it was like, oh crap, Ignite popped up, and 90% of my biotechs and startups are using it in 21, which was not the case in 2019 and 2020. Moving on a little bit to policy stuff, the good news here is there's actually been significant room. This is an area where BioTeam has hammered for years and years and years, but as I alluded to before, the easy approach was just to throw money at your storage systems and grow them and not really care about data governance, data discovery, data tagging, classification. That's actually really starting to change. If you look at the consulting projects that BioTeam is working on right now, we've only really got 2 projects going on where we're actually replacing a large sort of incumbent premise-based storage system, but we have tons of projects that are involving Gen 3 data commons or derivatives of that. We have multiple data governance and sort of data discovery projects going on. And then we're actually doing a number of large-scale sort of holistic assessments of organizations to really understand where the data is, where it comes from, how it has to move, and how to sort of aggregate it into an environment that the whole business can sort of leverage, exploit, and sort of analyze off of. So the good news here on the policy perspective is I've really felt that we've really punted on data governance and data management for many, many years, and it feels like the tides of changing. We're starting to have and it's showing in our consulting workload for the first time ever. If I had showed this slide last year, I probably would have 6 active storage redesign projects. Now I've got 2. So going back to the POSIX stuff here, the friction here for me is it's that whole friction between assuming that the dominant consumer of your scientific data is a human being browsing files and folders. I think that's a requirement that should be handled at the presentation layer. I don't think it's the design we should be concentrating on in 2021. It's clear that software, automation, and machines are going to be the dominant consumers of scientific data, particularly as we scale beyond petabytes. So one of the things we're really doing here is essentially really what it boils down to is there's no real one-size-fits-all. It basically just boils down to figuring out the best way to apply all of these technologies and the best way and the best place to inject this stuff. There's a lot of interesting meat to this, like organizational culture. Who owns data policies and who owns data replication? Org charts, where does this position live? Does this position report to the CIO, the CSO? Is this an IT position or a research position? There's a lot of really interesting sort of gnarly procedural, cultural, and org stuff that you have to get through as soon as you get serious about data governance and data management. So moving this on here to petabytes, I think I'm actually doing okay on time as well. Petabytes is kind of my catch-all category for just kind of the raw storage bits and what I've been sort of seeing here. And so I am gratifying to see that the growing trend of people interested in sort of data curation, data awareness is growing. That's been a particular sensitive point for me for a while. But if I wanted to look back over the last 18 months or so, really what it comes down to is petascale, big storage, buying it, acquiring it on the cloud, remote, hasn't been kind of scary in kind of a long time. So we've really got issues with data engineering, data movement, data ingest, and all of the standard management, curation, governance, and other type stuff. So I kind of really want to go back and talk drivers, some cultural stuff, and what I see kind of are going to be my challenges in 2022 and beyond. I will say the driver stuff I stole from last year's slide because I don't think it's actually materially changed for us. So, if you really want kind of the science-flavored view of what science does to IT, then we can just kind of go through this. Overwhelmingly, genomics and bioinformatics was this historically dominant driver. However, the big change, and actually this change has been around for quite some time, is images and image-based data are now the dominant storage type on scientific computing environments, and it's the fastest growing scientific data type. It used to be genomes and BAM files and FASTQs and things like that. Now it's cryo-EM images, it's TIFF images coming off of confocal microscopes, it's live video coming off of your live cell imaging incubator box or your animal facility or something like that. So that's really been one of the biggest changes, is seeing the sort of change in storage patterns go from basically genomes and files to image and video-based stuff. And honestly, we've had to redesign and rework some of our IT architectures to make that work. The other driver, I won't read this stuff for ML and AI, I've already talked about it. The problem with ML and AI is not only do you need a fast performant file system, you typically need a very broad view of your data because it always wants to go back and retrain or reclassify. So you now need to provide very big and very fast storage if you're going to keep your ML and AI people happy. And then finally, chemistry and molecular dynamics, they're usually the fairly easiest people to support. They tend to be CPU heavy and data light. The problem with the chemists is if you give them more GPUs and bigger compute, they just refine their simulations to ask more sensitive questions. A chemist can basically swamp an infinite amount of CPU or GPU. So the real issue in research IT is figuring out how few GPUs you can get away with to keep your business and your science going without bankrupting. And I'm serious, we work a lot at NIH and on BioWolf. The computational chemists and the protein folding folks, they will saturate 100% of the GPUs, and there are thousands and thousands of them all of the time. And if you give them another 5,000 GPUs, they're just going to dial the sensitivity of their simulation up and keep on rocking. It is an unwinnable problem with chemists and protein people. You just have to find the not going bankrupt versus doing really good science balance to keep them happy. I will say also, that is one of the drivers for premise-based HPC. GPUs are getting harder and more expensive to find in the cloud. I have to do region hunting all the time on Amazon to find GPUs for my chemists. If you have a 24/7 compute load that is GPU heavy and you really care about the economics versus capability, we're seeing a lot of GPU clusters going into premise systems because basically it's a guaranteed resource and the economics work out as long as you're keeping that GPU running for basically 24/7. If you have bursty workloads, cloud is still kind of better, both from a capability, technical, and also even cost perspective in most cases. And then finally, the only other thing that's starting to change is we're getting a lot of really different data types. I now have streaming data. I now have time series data, which could be anything from temperature streams coming out of a bioreactor in manufacturing that I now need to care about and feed into our analytical environment, all the way up through streaming data, which is often video, but it could be also other bits of data as well. And that typically is difficult to store on standard storage systems. You often need things that kind of look like databases. Basically, if you have wearables, sensors, streaming, or time series data, you probably need a new mix of products and a new mix of tech in your sort of research, IT, or discovery supporting stack. And so that means new products, new vendors, new things to evaluate, and new things to deploy. Or you just buy whatever the cloud vendor is particularly trying to sell you. In Amazon for streaming, it would be their Kinesis services. There's equivalents in Google and Azure as well. So finally, to kind of wrap up my bits, on the culture side, if I do have any claim as an influencer or someone who can kind of move the dial, then I'm going to use my bully pulpit to, shrilly hector you from the stage on a couple of things that I sort of feel important about. So, on the cultural side, I do feel like there needs to be kind of a mental shift between both the scientific end users and the IT people who support them, and it goes in a lot of different axes. But in particular, the concept of data as currency, and managing it efficiently in addition to not just spending it wisely. But the biggest issue really is that first bullet point. If you go into an environment and ask what files or what data do you have is most important to you, and the C-suite executive comes back to you with the all of our data is important answer, that's a red flag. That's a sign that you really don't know what you've got, and you don't know what you have, and you don't know how to classify between it. So that you can maybe use that as a gentle screening question within your organization to kind of see where you fall. If someone comes back with the answer, all of our data is important, red flag. It's time to dig in a little bit more. The second thing here is I'm really enthused with the idea of treating scientific storage as if it was a laboratory consumable. And this goes back to my conversations with scientists about how they pay for flow cells and how they manage those inventories. And I'm coming from an era where scientists were never quoted, storage was cheap, we just kept making it bigger, no one ever had to justify, no one ever had to budget, no one ever had to plan. But now we're in an era where there's petabytes of open access data available on the internet. It is incredibly operationally expensive and very, very difficult for me to support petabytes of open access data, let alone petabytes of data that your company has invested millions of dollars in generating or acquiring or collaborating. So I really like the idea of a cultural shift of treating storage, and particularly resources for scientific data, as a consumable resource in the same way that laboratory reagents are handled. And that basically means I expect the end user or the stakeholder to do a little bit of planning, a little bit of justification. I'm not really talking about budgeting or forcing chargebacks or showback levels, pay per terabyte of storage, but I'm at the point now where if a scientist wants a couple hundred terabytes, or if she wants a petabyte or two, she should probably be able to articulate why, what the business value is, what the scientific value is, and how long this stuff is going to be kept around. And so I'm trying to sort of encourage that shift of thinking of storage as something that's no longer infinite. It's something that we have to get our head around and treat as kind of a consumable. All right, that's my timer to sort of wrap myself up, so let me get going here. The second thing I really want to mention is when it comes to automated data management, IT has really failed. We did a lot of policy-driven stuff based on file access time or file age. We would make tiering decisions based on that. That does not align with the way scientists use and manage data. You can't archive data based on it hasn't been touched in 6 months. If the person's part of a project where they've been trying to get a paper published for 7 years, or they've been trying to get an IND accepted by the FDA for 6 years. Scientists manage data differently. They manage it by project, by program, or by department. And so the IT-based methods of last access time or file aging time have failed. So the cultural change I'm really sort of pushing here is the consumers and stakeholders of the data, the people who actually know how that program, that project, or that department runs, those are the people who need to make the tiering decisions, the data lifecycle decisions, or they need to be prepared to sort of feed that information to IT so that we can program our systems accordingly. Basically, the IT systems working on kind of weird, metrics just fall flat in the face of the way human beings and scientists actually consume their data. I think this is the final thing I'll end with is, for me, this is the social contract. My job as an IT person supporting scientists is to provide you a system that meets scientific and business requirements. It should be safe, available, and performant. Your job as the consumer is to sort of view storage and treat it sensibly, have an active conversation and be actively involved in managing it. And then we fall back on the joint responsibility. The single biggest operational hassle is large-scale data movement, large-scale data ingest. I can't tell you how many disasters I've seen caused by scientists FedExing hard drives around. That needs to stop, or if you are FedExing hard drives around, it needs to be an SOP'd procedure handled by dedicated people. So I think really that's where the joint interaction falls into. When it comes to data movement, data engineering, and ingest, that's kind of the shared responsibility model between sort of research and IT. I think I'm gonna skip the keep it tidy home stuff. The take-home message here is that There's been a lot of problems caused by people hoarding data in personal and home folders, and one of the design methods that I'm sort of stealing from NERSC and the supercomputing sites is nobody gets big storage in their home folder anymore. We only allocate storage on a project, a program, or a department basis. You know, the era of you having a couple of terabytes in your home folder and sort of hoarding your data and stuff, that's kind of over as well. We need to be sort of copying what the DOE, DOD, and sort of supercomputing sites have been doing in this space. So I'm going to skip the friction stuff because I'm already a little bit over time. I think I'm basically now, this is me. I'm going to sort of rusticate and go back to sit down, and I'm going to pass things off to Adam. And again, for those of you, especially for those of you who've seen me since 2009, thanks for your attention. Thanks for your feedback. And Trends is going to continue, but I think if they let me, I'm going to just fade into the background and let other people talk. So all right.